Next section in Unit 11 is 11.2. I can understand and perform rotations. So let's write rotations here, and dilations of figures. Now the warm-up question has nothing to do with math, but it is kind of an interesting topic. What happens when your pupils dilate? Now let me just mention this. A lot of times people pronounce the word dilate as dilate. They say their eyes got dilated. That's not correct. It's just two syllables, dilate. So just kind of keep that in mind. It's not a big deal, but just something that people often mispronounce. So what happens when your pupils dilate? Well, if you go to the eye doctor, a lot of times they give you some eye drops that dilate your eyes. And when they dilate your eyes, it makes your pupils bigger. Okay, so let's see. What happens when your pupils dilate? They get bigger. So they get bigger. Okay. Now let's remind ourselves of the two other transformations that we learned last year. We already talked about translations and we talked about reflections. There are four altogether, so this is kind of just rounding these out, so we're reminding ourselves of what these are. So I'm going to slide down here. The other two that we need to learn are rotations and dilations. Now you may already know something about these. So when we talk about a rotation, what we're talking about is turning around a central point. Usually the origin, that's usually the point around which we turn. So we've got a 90 degrees clockwise rotation about the origin. So we take the x and y and we switch them and we change the x coordinate to the opposite of what it was. We multiply by a -1. If we want to do the same thing but we want to go counterclockwise, so we want to do a 90 degree counterclockwise turn around to the origin, we switch the x and y, but this time we make the y negative. And then if we do a 180 degree rotation about the origin, then this one's kind of interesting. So what happens is we don't switch either one of them. We leave this here and we leave that there. So it's still x and y, but what we do is we make each one of them the opposite sign of what they used to be. So a couple of thought questions here, a little thought experiment. Why don't we need a direction on a 180 degree rotation? So we've got clockwise and counterclockwise on the 90s. Why not a rotation on the 180? Well, if you're pointed over here and you do a 180 degree rotation, so you're rotated over here, it doesn't matter whether you went in the clockwise direction or the counterclockwise direction, you're still going to end up 180 degrees, exactly opposite of the direction that you were originally pointed. Okay, and then why don't we need a 270 degree rotation? I mean, if we cover, let's say, a 90 degree rotation and then a 180 degree rotation, why don't we need a 270 degree rotation? Well, stop and think about this. If we were to rotate 270 degrees all the way around here, that's just like doing a 90 degree rotation the other direction. Okay, so that the 90 clockwise or the 90 counterclockwise would cover a 270 degree rotation. And then the last thing is we want to make sure that everybody understands what the word about means. So when we say we're doing a 90 degree clockwise rotation about the origin or a 180 degree rotation about the origin, what we mean is around the origin. So what that means is we're using the origin as the center point of rotation. So let's take a look at this problem right here in this example. It says write a verbal description and the mapping rule. So the verbal description is going to be easier to figure out. And I just want to point something out to you that you may have learned before, but you may have forgotten. We are going to bring this up a little bit later to make sure everybody gets this. So we've got the old one right here. So I'm going to put old here and I'm going to put new right here. One thing that you can do to find which direction it was rotated, because this is a rotation, we're using this as an example for rotations, is you can draw a line from the origin to one of the old points. So if I were to take one of the old points, let's take H. Okay, so H, I draw an arrow right over there. So this would be the direction that it used to be pointing, and now I need to draw a line from the origin to the new H, so to H prime. Okay, so it's over there. And take a look at what we've got here. What we've got here is a 180 degree rotation. Now again, it doesn't matter whether you go clockwise or counterclockwise, this is still a 180 degree rotation. So I'm going to shrink this back down, and we're going to say 180 degree rotation about origin. Okay, and then you do need to know these rules. Some of these get a little bit more complicated. It might take some time to commit these to memory. So the rule for a 180 degree rotation is, again, they don't switch places. So we've still got an X and a Y. What we do is we change the sign of each one of those. Now I'm going to take this one right here. So this one was back 4 and up 1. So this is -4, 1. So remember, what the rule says is they get to stay in the same place. So I'm just going to draw some lines down like this, but they do have to be multiplied by a negative. So the opposite of this would be 4, and the opposite of this would be -1. So let's see if that's where it ends up. Over 4 and down 1. That's exactly where it ends up. Okay, so the rule does work. We're in good shape there. Now let's talk about dilations. These are an enlargement or a reduction. So if we talk technically, those are probably the words that we ought to use. They are either a stretch or a shrink of that original figure. So with the dilation, we've got a scale factor. So you take the old x and y and you multiply x by a number and you multiply y by usually that same number, but we'll look at a couple problems where that's not necessarily the case. Now with dilations, it happens kind of like we were talking about before with stretches and shrinks with functions and stuff like that. So if c is larger than 1, then the figure gets bigger. Okay, it gets bigger. In other words, it gets stretched. Whoops, got an R in there. Stretched. Okay, and if it's less than 1, then it gets smaller, which kind of makes sense. It gets shrunk. Okay. All right, so let's take a look at this one right here. And these can be a little bit tricky. You've got to know what to look for here, which is why I've got a hint over here. It says identify the scale factor for the dilation, and then write the rule. So again, this is the old one right here, and this is the new one. So this is old and this is new. And what's happened here is it's definitely gotten smaller. So we are looking for a scale factor that's smaller than 1, okay? So what we usually use is we use a fraction. We do the new one over the old one to find that scale factor, and we're going to use f and we're going to use f prime. And what I'd like you to look at is why are those two the easiest points to use? Because we're going to use the x and y coordinate of f and f prime instead of using h and h prime or g and g prime. Well, you might notice that if we take a look at f, h, and g, those are all nice convenient points. They happen to be on nice intersecting. They've got integers for coordinates, but f prime is 2, 2, and h is, let's see, that would be 1, 1.5, and g would be 2, 1/2. Okay, so using those fractions would be a little bit more difficult. It's not that you couldn't, it's just we want to do this as easy as possible. So here's what we're going to do. This is the point 4, 4, and this is the point 2, 2. Now it doesn't matter which one you use as long as they had the same scale factor in the dilation. So what we're going to do is we're going to do the new one over the old one. So the new x coordinate is 2 and the old x coordinate is 4. So if we reduce that, we end up with 1/2. So this would be 1/2 x. Now if you wanted to do the same thing to find the scale factor in the y direction, you could, but it's still a 4 and a 2, so it's going to end up being 1/2. So we're going to put 1/2, y. Now if you wanted to do decimals for that, that's totally okay. I kind of like fractions better, so I'm just going to leave it that way. All right, now, please note there is something very different about dilations as opposed to the other three transformations that we've talked about. The figures are no longer congruent. They are no longer the same size and the same shape, and this is why we don't spend a lot of time working with dilations of figures. What we're interested in is we're interested in those transformations that preserve the size and the shape of the figure. We want the angles to be the same size, and we want the length of the sides to be the same size, and this is what makes them congruent, and that's why we're interested in those. Now, for the most part, we can do translations and the reflections, the stuff that we did last time. You can kind of do those without the rules. It might be good to refer to them, but translations especially, those are pretty easy. You can do them without the rules. Rotations and dilations are a little more difficult. So most of the time, it's a really good idea to write down the coordinates of the points and then use the rules to change those. And you'll see what I mean right here. Because on this mapping one, it says, go ahead and perform the indicated rotation, and it says use proper notation. So if you can just go through and say, oh gosh, all I need to do is switch the x and the y, and I need to make the x the opposite of what it used to be, that's totally okay. But generally, a lot of people have a hard time doing that. So here's what I'm going to do. And you've seen me do this before. I'm going to list what A, B, and C are. So A is -2, 4. B is -1, 1. And C is -5, 2. Now the rule says what we need to do is we need to switch these and multiply the x by a negative. So here's what I'm going to do on this. I'm going to draw a little line that says we're going to switch places, and then when I move the x, when I move this one over here, I'm going to put a -1 right there. So when I move this over here, this becomes a 4. When I move this one over here, it gets multiplied by a negative, so this becomes a +2. So this is going to be A prime. Same thing here. We're going to move this, and then this one gets multiplied by a negative. So we're going to have a 1 here, and then these get multiplied by a negative. So -1 times -1 is 1, and that's going to be B prime. And then C, again, we're going to switch these. That one's got a negative on it, so this is going to be a 2, and then that's going to be a 5, and that's going to be C prime. So again, the ones that we're going to graph are this one, and this one. We're going to graph the new ones. So let's see what this looks like. A prime is at 4, 2, so over 4 and up 2. So there's A prime. B prime is 1, 1, so 1, 1 would be right there. So there's B prime. And then let's see, C would be 2, 5, so 2, 5. 2, 5 would be right there. So there's C prime. All right, so we're going to draw these lines right here. Now, I'm really not 100% convinced that this is actually congruent or anything, or that there's something going on. This is kind of a hard one to see, so here's what we're going to do. We're going to, again, mark this one with old and this one with new. And I'm just going to take two really easy points. I'm going to draw a line from the origin over to here, and then the origin over to here. This is the old one, this is the new one. So what happened is it rotated this way. Okay, so this was a clockwise rotation of 90 degrees. All right, now it didn't say we had to figure that out, but it's a good thing to be able to do. All we need to do is just be able to carry those out. Okay, so 180 degrees clockwise rotation about the origin. So remember what happens here is we need to switch the x's and y's, at least their signs. So the old x and y turn into a new x and a new y. They stay in the same place, but they both get multiplied by a negative. So if you wanted to, this would be one where maybe you could get away without listing what they are. Whoops, let's put a B prime here, and let's put a C prime here. So this one is, let's see, -2, 4. So that would turn into 2, -4. Okay, we just take the old coordinate, -2, change it to a positive. Old y coordinate 4, change it to a negative. Okay, this is -1, 1, so we're going to be 1, -1. Again, the old x coordinate was -1, so we make it +1. Old y coordinate was 1, so we make it -1. And then this one is -5, 2. So -5, 2 would be 5, -2. Okay. Again, if this was -5, 2, all we're doing is changing the sign of each one of those. They get to stay in the same place. So let's see what happens here. This should be recognizable as a 180 degree rotation about the origin. So let's see what we've got. 2, -4, so 2 and -4 right here. So there's A prime. 1, -1, so right here there's B prime. And then 5, -2, over 5 and down 2, so there's C prime. There we go. And if this is a rotation, now notice you might be tempted to look at this and say, gosh, that kind of looks like that's a rotation or a reflection. It's not. Okay, those do not look the same. It would not have a line of symmetry here. This is definitely a reflection. Or a rotation here. And again, we were pointed this way on this one, and we pointed in exactly the opposite direction on the other one. Okay, now it says, please note at least 2 corresponding angles or sides on the pre-image and the image. So let's just go through and note a couple of those right here. So you'll notice on this one, see the size of that angle right there? See how it's the same size right here? So I'm going to write down that angle A is congruent to angle A prime. And we could mark down that side AB, so side AB is congruent to side A prime, B prime. Whoops, A prime, B prime. I can put the line on there in just a second. Okay. Now we can do the same thing for each one of those. That would be a good idea. But again, you can kind of see angle B is congruent to angle B prime. And we could do side AC is congruent to A prime, C prime. So we could mark some things down like that. Okay, all right, so let's go ahead and take a look at the other side. Okay, on the second side, I've got the rules for rotations listed down here. Dilations, we'll deal with those again in just a minute. Those rules are a little bit easier because it's only got that scale factor of C in there. So notice on example 2, it says, write a verbal description and a mapping for each transformation. Remember, it might be good to write old and new, old next to the pre-image and new next to the image like we've been doing. And then again, a reminder, if you need to figure out which way it was rotated or what's going on with the dilation or whatever, it's a good idea to write old next to the old points and then new next to the new points to see which figure it was rotated and how many degrees and stuff like that. So let's take a look at a description here. This is, again, we're only dealing with rotations and dilations. So this has definitely got to be a rotation of some sort. So I'm going to go ahead and write next to this one. I'm going to write old next to this one and new next to this one. So I'm going to draw a line from the origin right to one of the old points. So if I draw a line to S, I need to draw a line to S prime. So that would be over here. So this is from old to new. This is the old one to the new one. So we went this direction. So this is a 90-degree counterclockwise rotation. So I'm going to write 90 degrees counterclock. And that's good enough. If you wanted to write counterclockwise rotation, I suppose you could too, so we get completely technical about this. And then the rule, this is why we might need these. It's going to take some time to get these down, so this is why they're up here. If we do a 90-degree counterclockwise rotation, remember for the 90-degree ones, they each switch places. Okay, so we're going to do a Y here and we're going to do an X here. So however you get this straight, it's the X that changes for clockwise and it's the Y that changes for counterclockwise. So we'd put a negative Y right there. And if you wanted to check some points and just make sure that that works, you'd be welcome to do that. On this one right here, again, there's no way that this is a dilation. We didn't stretch it or shrink it at all. So I'm going to draw a line from here to the old one. Again, this is the old one and this is the new one. And then draw a line right here. So whether we rotate it this way or this way, this is going to be a 180-degree rotation. So 180-degree rotation, and again, we'll get technical about this, about the origin. Now, it is possible to rotate around other points, but we typically don't do that. Rotations about the origin are by far the most common and the most useful, so we'll stick with that right here. And let's see if you can remember what the rule is for this, because we've done this once before. Remember, a rotation about the origin, 180 degrees, we don't change the X and Y position. So there's still X and Y, but we do change their signs. So one thing we could do really quickly is check this one right here. This one was, let's see, back 4 and down 5, and take a look at this. All we're going to do is we're going to go to 4, 5, over 4 and up 5, and there we are. Okay, so that rule definitely works. And then this one right here, we need a description on this one. This is definitely a dilation. You can see what looks like the state of Nevada or something. The old one is the small one, and the new one is the big one. So I'm going to write old. I always have a tendency to write that backwards. Old and new. Okay, and then we're going to take some key points. Now on this one, you'll notice, my gosh, every single one of these sets of points, they're all nice values. So we could pick any ones that we want. So I'm going to take this one right here. This one's 2, 2, and this one's 4, 4. And then again, we always do the new one over the old one. So the new one is 4 and the old one is 2. So that means our scale factor is 2. So we're going to say dilation, scale factor of 2. So that means it got twice as big. So to write this rule, we do 2x, 2y, and then we're good to go. Okay. Now, down below here it says, are all the corresponding angles and sides congruent on the transformations up above? Well, let's take a look at this. So if you look at angle B prime and angle B, those look like they're congruent. If you look at the line from L prime to S prime, those are about the same length and so forth. Same thing here, we could match these up, but not on this one. So the answer here is no. So we're going to say not on C, not on example C. Example C is a little bit different. So we're going to take a look at 2 more dilations, and we're going to see why they don't preserve size and shape. In other words, why they don't make the image congruent to the pre-image after the transformation. So we're going to come down here and take a look at example 3. So it says, draw the image after the given transformation. So we're going to take any xy pair and we're going to change it to 3x and 3y. So again, we call the number that we multiply the numbers by, we call that the scale factor. And sometimes you'll also hear it referred to as a constant of proportionality because we proportionally made things bigger. But it's much more common to call it a scale factor. So what we're going to do here is we're going to take each one of these points and we're going to make them 3 times bigger than they used to be. So I'm going to write down T and S and D. And T is the point 2, 1. And S is the point 2, -1, and D is the point 0, -1. And what we're going to do is we're going to transform each one of these. So I'm going to have a t prime, an s prime, and a d prime. And the rule says that we need to multiply everything by 3. So multiply the x coordinate by 3. So this is going to be a 6. Multiply the y coordinate by 3. So that's going to be a 3. Multiply this coordinate by 3. So that's going to be a 6. That's going to be a negative 3. And then multiply 0 by 3. That's still going to be 0. And then this is going to end up being a negative 3. Now, we're not going to worry too much if this ends up being off the charts, which it looks like it's going to be, because I think it's just a little off there, and we can still kind of tell, what's going on roughly with this scale. So 6, 3. So over 6, that would be about right here, and then up 3. So we're going to put a point about right there. That would be t prime. And then s prime is going to be 6, negative 3. That's going to be down here, so that's going to be s prime. And then d prime is 0, negative 3. So 0, negative 3, so we're going to be right there. So this is d prime. So we'll draw a line connecting those, connecting these, and connecting these. Okay. Now you can see that this image is much bigger than the pre-image. But what I'd also like you to note is this angle is still the same size as that one right there. If we were to take out a protractor, it's still the same size, but it's the side lengths that have got much, much bigger. So the image is no longer congruent to the pre-image, okay? Now, if we come over and take a look at this guy right here, this one is a little bit strange. So what we're going to do on this one, we're going to take the same one. So this is going to be T, S, and D, and again 2, 1, 2, negative 1, sorry, 2, negative 1, and what do we have here? 0, negative 1, and we're going to multiply the x's by a half, so that's going to give us 1 and 1, and if you multiply that by a half, you still have 0, and then let's see, we're going to multiply this by 4, so that's going to be 4. That's going to be negative 4, and that's going to be, let's see if we multiply that by 4, that's going to be negative 4 also. Okay, so at least we get some decent points to graph. So this is going to be 1, 4, so over 1 and up 4, so we'd be right there. That's t prime. And s prime would be 1, negative 4, so that's going to be way down here. There's s prime. And then d prime would be 0, negative 4, so that's going to look like this. So what we get here is a really weird shape. This is a really tall, skinny triangle. Okay, now clearly the angles are not the same size, and the sides are not the same size. Okay, so dilations do not preserve the size of sides even when they can preserve the sides of angles. And again, you could make a comparison right there. Oops, looks like I missed a set of parentheses right there. Okay, now as long as the scale factors are the same in the horizontal and vertical direction, the figures will be similar. So you'll notice on this one right here, we had a different scale factor in the horizontal x direction than we did in the vertical y direction. These two triangles really have nothing to do with each other as far as size and shape goes, but these two triangles do. These have angles that are all the same, like this is still a right angle here and that's a right angle there. So this one is similar, okay? So the figures will still be similar as long as the scale factor is the same in each direction. So again, that symbol means similar, okay? All right, let's go ahead and take a look at the self-assessment here, and then we'll do problem 1 from the practice assignment. So I've got 11.2 up here. Again, we're only working on rotations and dilations, so you don't need to worry about reflections or translations on this assignment. So the instructions say graph the image of the figure using the transformation. So it's going to give you a transformation, and then it's going to tell you what to do there. So on this one, you'll notice that it's just a point. It's not actually a figure. Now, there are other problems on here that are figures, but on example 1, it's just this point A. Now, remember, on a rotation of 90 degrees, remember, the x and y's both switch places, and one of them changes sign. So if you can remember what that one is, then you're in good shape. If you can't and you need to refer to it, that might be okay. So remember, they're going to switch places, and one of them is going to change sign. So let's see what it is. We're doing a counterclockwise rotation. So remember, counterclockwise. For me, the way I like to remember it is, okay, on 90, they're going to switch places, and one is going to change sign. If it's clockwise, X is kind of my more favorite than Y is, so that one changes. And if it's counterclockwise, it's going to be the Y. So here's what's going to happen on this. We're going to take the old XY pair on this one. So this one is back 4 and up 3, so negative 4, 3. And what we're going to do to get to the new one is we're going to switch places, Okay, and we're going to multiply whatever the x was, or sorry, whatever the y was by a negative. So this is going to be here, that's going to be a 4. This is going to be a 3, but we multiply it by a negative. Whoops, that should be a negative 4. And then we're going to get a negative 3, negative 4. So we're going to go negative 3 and negative 4, so that would be right here. So we're going to put an A prime right here. Now, to double check and make sure that this actually works, I'm going to switch colors and I'm going to draw that line from the old one. Okay, there's the old one, and then here's the new one. And does that look like a 90-degree rotation in this direction right here? So I'm going to go ahead and put a big fat point there, and this is negative 3, negative 4. That's all you have to do on this one. All right, good luck with the assignment.